Hey everyone, we're going to look at number 14 in section 3.5, and we're given a figure with three graphs. There's a blue one, red one, and green one. Hopefully, if you're colorblind, you're not going to have too much trouble with this. F prime and F double prime, we're going to determine which is which. Okay, so what I would look at is, let's just start with the red graph. Could this be either F or F prime, meaning that its derivative would have to be one of the other graphs? Well, the derivative of the red graph, notice right here at the bottom where we have this local minimum, the tangent line would be horizontal, so the derivative would be equal to 0 there. So let's move down at that value of x, right about here. The derivative would have to be 0. Is any of the graphs 0 at that point, at that value of x? No. Same thing at the peak here, the local max on the red graph right there. There will be a horizontal tangent line there, and the derivative right there is 0. Is there a graph that crosses the x-axis or touches the x-axis there? No. The blue one's close, but it's not lined up with where the derivative would have to be 0. And same thing here. It looks like the derivative is 0. This looks like x equal 5. Right at x equal 5, there's no function that's 0 there. So I would deduce right now that this red graph cannot be f because its derivative is not here, and it can't be f prime because its derivative, which would be f double prime, is not there as well. So my guess is the red one is f double prime. Okay, let's take a look at the green one. Okay, the green one, notice at x equal 1, we have very close to x equal 1, we have a horizontal tangent line at that local max, and the derivative had to be 0. Well, the blue graph is 0 there, so I mean that's a start. Let's see some other points here. The green graph has a horizontal tangent line right there at that local min, and the derivative is 0 there. Notice the blue graph is 0 there. And then at this little local max here on the green function, we notice the derivative is 0 there as well. And we move down at that same value of x, the blue graph's derivative is 0. So it looks like the green graph, its derivative is the blue graph. Okay, let's just confirm that too. We see at about x equal 1, the green function has a horizontal tangent line, so the derivative is 0, which is true for the blue function right there. And then notice for values less than x equal 1, the derivative at any point, if I draw the tangent line at any point on this graph of the green function, the line would be increasing, right? Which means the slope is positive. The slope is positive on the interval from 0 up to about 1 because the green function is increasing, right? So that means the derivative would have to be positive. Well, look at the blue function. Its values are all positive. Now they're positive initially at 0. It's positive about 1.5 here, and then it moves down to 1, down to 0.5, and then eventually gets to 0. So it's going down. And that's true because as we move from left to right along this green curve, the derivative is positive, but getting smaller, closer and closer to 0. And then what happens after the point where it's 0, then on this section of the graph where it's decreasing, the derivative is negative. And notice that's exactly what happens to the blue graph. It becomes negative. And we continually get more negative until some point in here, right? We reach a maximum negative slope. Then the slope is still negative, but getting closer and closer to 0 at this point, right? And that's exactly what the blue graph does. And then the graph of the green function is going to have a positive slope, and the blue graph is above the x-axis until it's 0 again. And then this section of the green graph has a negative derivative, and therefore the blue graph is negative. So the derivative of the green is the blue. Okay. And then let's look at the blue graph. It's going to have a derivative where we have a horizontal tangent line right here at the local minimum. We'll have a horizontal tangent line, and that corresponds to the red graph where the red graph is 0. Hey, that's good. Also, the derivative up at this local max for the blue graph, right, is going to be 0. We move down, the red graph is 0 at that point. And notice in between those 2 points, the blue graph is increasing, so its slope is positive. And the red graph have values that are positive, right? The value of the red graph is positive. And where the blue graph is decreasing between 0 and this value of x, whatever that is, just shy of 2, the graph of the red function is negative indeed. Okay. And it's kind of reaches sort of a maximum negative value right here. And then as we move along this section of the curve, it's negative, but getting closer and closer to 0, which is what the red graph is doing. And then the blue graph on this portion of its graph is decreasing again, and notice the red graph is negative. So the derivative of the blue graph is the red graph. So let's start again. Green graph, we said derivative is blue. Blue, derivative is red. Okay. So which is which? So the graphs are numbered here, by the way. I didn't mention that. These numbers here are numbering. So the red graph, I'm calling the red graph, if you're colorblind, that's number 1. Sorry, number 1. The green graph here is number 2, and the blue is number 3. So we said green, right, is derivative is blue, and the blue derivative is red. And so 2 must be the function f. Its derivative f prime is blue, which must be 3. And then 1, as we said, must be f double prime. So 2 is the graph of the function f. F prime is graph number 3. And f double prime is the red one, or graph number 1. Let's hope that I got that right with all that. Yay. Okay. Hope this is helpful for this problem.